Hello everyone. In this video, let's discuss how to write a program to find binary tree level order traversal. Given the root of a binary tree, return the level order traversal of its nodes values. That is from left to right, level by level. So here they have given an example of binary tree, which is 3 is the root, 9 and 20 are the children of 3, and 15 and 7 are the children of 20. So the input is given as 3, 9, 20, and for the node 9, it doesn't have any children, so null and null. And for the node 20, we have two children, 15 and 7, so 15 and 7. So this is a given binary tree. I need to print the result in level order traversal. So I have to take a 2D list. So here, first level I have 3. Okay, in the first list I have 3. In the second level I have 9 and 20. That should be a separate list. And in the third level I have 15 and 7. That should be a separate list. The second example, they have given only 1. That is the root value that should be printed. If the tree is empty, I have to return an empty list. This is what they have given as an example. Now let's try to understand the logic of the program. Okay. So here they have given a binary tree. So here let's take a root. And the root value is, I'll give it as 100. The address of the root I'll give it as 150. Okay. Fine. Now we have to start the iteration. So first I have to take a 2D list. Why? Because I have to return a 2D list as my return value from the function. So I have to declare a 2D list. So I'll take list. I'm going to store an integer value. So integer. The name I'm going to give it as result is equal to new array list. Okay. So I have taken a 2D list here. Fine. So let me take a 2D list as result. Okay, this is my 2D list. Fine. Next, what I'm going to do is I have to check whether my root is equal to null. What is the root value? Root is having the value called 100. Check if root equal to null. If root is equal to null, what I have to do? I have to return result as an empty list, because initially the list is empty, right? If the root is equal to null, I have to return the result, that is 2D array. In case if the root is not empty, we have to print the level order traversal. So level order traversal can be performed with the help of a queue data structure. Okay, so I'll be taking a queue here. So let me take a queue here. Okay, so here I'll take queue. So this is my queue. Next, what I have to do is, initially, whatever the value which is in the root, that has to be stored in the queue. That is, it has to be inserted inside the queue. So first, let's declare a queue. Queue. Here, I am not going to store the value. I am going to store the address. So I have to give tree node. Queue name I give it as queue equal to new linked list. Okay, I have declared a queue. After declaring a queue, I have to insert the root value inside my queue. So queue dot offer root. So what does the offer method do in the sense? It will insert the, or I can say it will add the value inside my queue, and it returns true if the insertion is successful. It will return false if the insertion is not successful. That is what the offer method does. And it will not throw me any exception at all. That is why we are using a method called offer. Now what am I going to do? I am going to take a root value that is 100 that I am inserting inside my queue. Done. Next, I have to check whether my queue is empty or not. How can I know whether my queue is empty? Not of queue dot is empty. If the queue is not empty, what am I going to do is I will go inside the while loop. I will go inside the while loop. I will be taking a list. So I will be declaring a list. I am going to store only integer value. The list name I will give it as current equal to new array list. So I have taken a list. So here let me take a list. Fine. List name I am giving it as current. Okay. So this is a 1D list and the result is a 2D list. Fine. Now we have to print the values by level. So for that, find the size of the queue that gives the total number of elements in that particular level. So int level is equal to q dot size. Q dot size gives me the total number of elements in that particular level. Now q size is 1. So in the first level I have only one element. Okay. Levels value is, I will comment here, the value is 1 as of now. Q size is 1. Now I will be taking a loop and I will be iterating up to level times. So for int I is equal to 0, I less than levels I plus plus. Okay. Now I'll go inside the for loop. Now what am I going to do is I have to find the current node. So how can I find the current node? In the sense I'll be taking 3 node current node, right? So I'll give current node is equal to, from the queue I'll pop the front element. So q dot poll. What does the poll method do? In the sense it will pop the front element of the queue and return that particular element. So here what is the front element of the queue? 100. So I'll take current node. Okay, so this is a current node. I'll pop the front element of the queue, that is 100 will be stored in the current node, and the value 100 will be deleted from the queue, because the method poll will pop the front element of the queue and that will return. So here where it is returning? To the object called current node. It has been returned here. Afterwards, I have to take the value from this particular memory location. So how can I take the value from this particular location? Current node dot val will give me the value. So that I am going to insert it inside the list called current. So current dot add, in the list current I am going to add current node's value. So here current node is 100. 100's data is 3. I am going to take 3, that I am going to store it in the list current. Afterwards, I have to take the left child address and the right child address. I have to insert inside my queue. For that, I have to check one condition. If the left child is not empty, I have to insert. If it is empty, I don't want to do anything. For that, I have to write the condition as if current node dot left is not equal to null. Check, current node is pointing to 100. That is dot left is 200. That is not equal to null. If it is not equal to null, okay, in the queue I have to insert q dot offer. Offer method will add the element. If it is present, if it is not present, it will return false. After insertion, it will return true, as we have discussed earlier. Q dot offer, current node dot left will be inserted. So here current node dot left is not equal to null. So I'll insert that inside my queue. 200 have been inserted. Then check the next condition. What is the next condition you have to check? If current node dot right not equal to null. So here current node is 100, current node dot right is 300. So that is not equal to null. If the condition is true, what I have to do? I have to insert q dot offer current node dot right. So current node dot right is 300. That should be inserted inside my queue. I'm done with this. Okay. Next, what I have to do? I have to close the for loop. So here I value is 0, 0 less than 1, the iteration got over. Now I will go for the next iteration of my for loop. I value will be incremented by 1, condition becomes false. 1 less than 1, it is false. I will come out of the for loop. After coming out of the for loop, the 1D list we have, right, that should be inserted in a 2D list. So result dot add current. So 3 is stored in the list called current, that should be inserted in a result. So in the 2D list I have added this 1D list. Afterwards I have to close the while loop. I have closed the while loop. Now I will go for next iteration. Check whether my queue is not empty. Yes, queue is not empty because it is having 2 elements. The queue is not empty. Now I have to declare current. So newly it will be declared once again because I have been for the next iteration. Now I will be finding the levels. So which means in this level how many elements are there. How come I know in this level how many elements are there? In the sense, find the size of the queue, that tells me how many elements are present in this particular level. So size of the queue is 2. So now level value is 2. So that tells 2 elements are present in this particular level. So I have to iterate the for loop for 2 times. For I equal to 0, I less than level. 0 less than 2, condition is true. If the condition is true, I have to find the front element of the queue, that should be deleted and that should be stored in a variable. So front element of the queue is 200. That will be popped and that will be stored in current node. So now current node is 200. So I have it in my queue that has been popped, and that should be stored in an object called current node. Done. After this, I have to take the value from the current node that should be stored in 1D list. So this is a line current dot add current node dot val. Current node is 200. 200 dot val is 9. 9 will be taken. That will be inserted in current. Okay. Afterwards, I have to check whether left child is not empty and right child is not empty. If it is not empty, I have to insert inside my queue. Here, by mistake, it is actually null. I should do it here as null. Yeah. So here, current nodes dot left is not equal to null. Condition becomes false because it is equal to null. I'll not go inside the if condition. And the current node dot right is not equal to null. Actually, it is null. Condition becomes false. I'll not go inside the if condition. I'll go for the next iteration of my loop. When I go for the next iteration, now I value becomes 1. 1 less than 2, condition is true. If the condition is true, what I have to do? I have to delete the front element of the queue that should be stored in the current node. Front element of the queue is 300. That should be stored in the current node. Fine. So this will be done by the method called poll. Poll method, what does it do? It will delete the front element of the queue and it will return the deleted element. So I have deleted the front element of the queue and it returns the deleted element that has been stored in an object called current node. Next. Now current node's value has to be added in the list, that is in 1D list. Current node is 300 now. Current node's value is 20. So here this I already have added. Now current node's value is 20. That should be added in the list called current. So 20 will be added in the list called current. After adding this, what I have to do? I have to check whether left child is not empty, right child is not empty. If it is not empty, I have to add that particular address inside my queue. So current node's left is 500. That is not equal to null. I'll add inside my queue. And current node's right is also not equal to null. I'll add 600 inside my queue. Done. After that, I'll go for the next iteration of my for loop. I value becomes true. 2 less than 2, condition becomes false. I'll come out of the for loop, which means I have added all the elements of this particular level that should be added in the 2D list. So current is a 1D list that should be added in a 2D list, which is 9, 20. So 9, 20 I have. See, like this. First I have 3, then 9, 20. Now I'll go for the next iteration of my while loop. Check whether my queue is not empty. Yes, queue is not empty. If queue is not empty, what I have to do? I have to declare a 1D list called current. Fine. Now levels I have to find. So how to find the total number of elements in this particular level? Find the size of the queue. So size of the queue is 2, which means in the third level I have 2 elements. So here the size is 2. Now I iterate the for loop for 2 times. So first time when I iterate, first what I have to do? Pop the element from the queue. Pop the front element of the queue, that is 500, and that should be stored in current node. So that will be stored in current node. Now it is pointing to the memory location called 500. After that, I have to take the value of the current node, that is 15. That should be added inside my list. So 15 will be added inside my list. After adding, check whether left child is not null. It is equal to null. Check right child is not null. That is also equal to null. Both the if condition becomes false. I'll go for the next iteration. When I go for the next iteration, I value becomes 1. 1 less than 2, condition true. I'll go inside the for loop. What I have to do? Delete the front element of the queue. Assign it to the current node. Okay, done. Afterwards, the current node is pointing to 600. Take the value from the current node. That should be added in the list. After adding it into the list, what I have to do? I have to check whether left child is not equal to null and right child also not equal to null. Left child is equal to null, so I'll not go into the if condition. Right child also equal to null, I'll not go into the if condition. I'll go for the next iteration of my for loop. Condition becomes false. I'll come out of the for loop. Now in the 2D list result, I have to add the 1D list current. So which is 15, 7 will be added. Done. Now I'll go for the next iteration of my while loop. Check whether queue is not empty. Actually queue is not empty. I have completed all the elements of the binary tree. I'll come out of the while loop. After coming out of the while loop, what I have to do? I have to return the 2D list result. I have to return the 2D list result. That's all. So this result will be written 3, 9, 20, 15, 7. 3, 9, 20, 15, 7. That's all. Now let's try to implement it as a program. First I have to declare a 2D list. So list, I'm going to store an integer value. The name of the list I'm going to give it as result equal to new array list. So linked list, array list I'll give. I have taken an array list. Now I have to check the base condition. If root is equal to null, I have to return the result, that is empty result has to be returned. If the root is not equal to null, I have to perform the level order traversal. For that I have to declare a queue. So queue, in queue I am going to store the address, so I have to give tree node. The name I'll give queue is equal to new linked list. Done. Now I have to add the root value inside my queue. So queue dot offer root, that I have added. Now I have to check whether my queue is not empty. So is not of is empty. So what is empty? I forgot. Actually it should be queue name. Queue dot is empty. If the queue is not empty, what I have to do? First I have to find the size of the queue. So why am I finding size of the queue? To know how many elements are there in that particular level. Before which I have to declare a 1D list. So list integer current equal to new array list. Okay. Afterwards I have to find the levels. So here how many elements are there in this particular level. So that can be defined with the help of the size of the queue. Queue dot size. Now take a for loop, I iterate up to level time. So I equal to 0, I less than levels, I plus plus. Now what I have to do? First I have to take the current node. So tree node, current node equal to, I have to pop the front element of the queue that should be stored in the current node. By using the method poll, we can do this. Now after this, I have to add the value in the list current. So current dot add current node's value. So the value I have added. After that, check whether left child is not equal to null. So current node dot left not equal to null. If it is not equal to null, I have to add it in the list. Sorry, I have to add it in the queue. So queue dot offer current node dot left. If the right child is not equal to null, I have to insert inside my queue. Current node dot right. Once it is done, I have to add it in the result. So 1D list has to be added in the result. Fine. Finally, I have to return the result. That's all. Now let's run the code. As it passes the test cases, let's submit the code. As it passes all the test cases. That's all.